So we'd talked a little bit some time back about converting all of these different video formats into analog VGA and feeding it into a 4x3 monitor for the purposes of hooking a whole bunch of old computers with widely varying video standards to the same screen through some kind of electronic switch. We were going to use analog multiplexer ICs, and there are some videos about that back there. I'm going to get back to that project one of these days. We were going to be able to do a regular 31.5 kilohertz VGA like NSVGA and stuff like that, and also 15 kilohertz analog RGB by including a GBS 8200 in the setup, as well as composite video by including a composite to VGA conversion board in the setup, and also CGA, EGA, and MDA / Hercules graphics using a resistor bridge DAC and an XOR gate to generate composite sync for the GBS 8200. So that pretty much covers all of the video formats that we might want to use. There are probably some that I'm missing, weird ass, like some of the older Macintoshes would only run right on fixed frequency 512 by 384 screens, and those would be impossible to hook up to something like that. But the only old Mac I've still got's a 2CI, and it'll work fine with a VGA adapter. Anyway, what I didn't talk about in all of that was, in much detail anyway, was how I planned on handling the pardon me. I haven't had all my coffee yet this morning. Was how I planned on handling the keyboard and mouse switching, and that was going to be something technically entirely separate from the video switching. It's just that the software that handled the switching would switch them both to the same thing at the same time. So what I was going to use for the keyboard and mouse handling were Wi-Fi enabled microcontrollers, and I have a selection here, different ones for different purposes. The one that I'd like to use as much as I can, this is an ESP01S Wi-Fi microcontroller module. It's basically an ESP8266 that only costs $3, and it's designed to be a serially controlled Wi-Fi module for Arduinos. But you can flash firmware to it if you've got like a TTL serial thingaroo. And the pin header is pretty small. It's got, of course, RX and TX serial pins on it. It's got 5 volt, 3.3 volt ground, and 2 GPIO pins. And those are 3.3 volt GPIOs, but we can get around that with like a 10-cent integrated circuit and a couple of resistors, you know what I'm saying? Maybe even just use a transistor to step it up to 5 volts. And like super cheap out in order to talk to like PS2 keyboard ports and stuff like that. Most of the old keyboard protocols, PS2, ADB, I don't know about the Sun type 3 to 5 keyboards. I don't know how many lines they use, but at least for ADB and PS2, we just need a data line on a clock line, as I recall. Now, ADB has a power on line or something as well. I'll have to read some documentation. I can't remember. In any case, hopefully, since this is the cheapest option we have, we'll be able to use it for a lot of different keyboard protocols. PS2/AT, the XT keyboard protocols. Hopefully it'll work for that fine. That only requires clock and a data line as well. So that'll be a lot of the hardware, and if we can do that for, you know, $3 a pop plus a connector, and then just like suck heat shrink tubing around the whole thing, and then it can just hang off the keyboard port in the back of the machine, that would be pretty cool. That would be cost effective for sure. Now this right here, this is a this is a generic clone of the Arduino Leonardo. I think it's an ATmega 32U4 microcontroller, and the thing that these are a little bit more expensive. These, well, they used to be like $4 or $5 a piece if you bought more than 5 at a time, but in these unprecedented times where you can't get any chips, the price has gone up a little bit. But hopefully one of these days things will straighten out and we'll be able to get them for reasonable prices again. Now, the nice thing about these is, pardon me, they've got lots of GPIOs, as you can see. They support I2C and SPI. They've got a serial port on them, but the most useful feature of these is that the USB port on them, unlike on the ESP8266 and ESP32 here, that both have USB ports as well, but the USB port on this one can be programmed to act like a USB human interface device. So you could hang this off of a USB port on a computer and it can act like a keyboard and a mouse and even a joystick. The problem is these modules don't have Wi-Fi built into them, but we could use one of these serial modules wired up to it to provide Wi-Fi access to this thing. So the keyboard scan codes would come in over Wi-Fi and go through the serial interface to the this is a Teensy 2.0 clone. I'll call it the Teensy then, for our purposes here. Go from there to the Teensy, and then the Teensy would convert it into a USB HID protocol and into the computer. So that's a little bit more expensive option, but there is an ESP32, a new one, the ESP32S2, that includes a USB controller that can be programmed to act as a USB human interface device. But I think they're like $15 or $20 a piece. It's a dev module similar to these, just a little bit newer version. And doing this, you know, if you can get this for $4 and this for $3, that's still cheaper, you know what I'm saying? And this will all power off of USB. You can power this thing off of this, which will power off of USB. So that's a way to get USB support, and as well USB game controller support and mouse support too, not just keyboards. So that's pretty useful. For these, if you wanted to have a PS2 mouse hooked up to the machine as well, you'd have to have 2 of them, because there are only 2 GPIO ports on that. So it may still, I don't know. Now here, actually, you might be able to use one of these for that. This is the full featured ESP8266 module. It's the same chipset that's on these, but it's got a lot more GPIOs. So they're once again 3.3 volt GPIOs. These used to be like $5 or $6 a piece, I think. They've gone up a lot now in these unprecedented times. I think they're like $10 or $12 now. Kind of ridiculous. But yeah, they've got lots of GPIOs. The problem is, like we were saying before, the USB port on these can't act as a USB human interface device, but you could still bit bang PS2 protocol, or perhaps ADB or whatever on these GPIO ports. I think it's got a serial port, and it also does I2C and SPI as well. And I think it may have some PWM and analog pins as well, but we wouldn't need those for farting around with keyboard protocols. And then finally, there's the most powerful option, the ESP32. Although this particular version can't act like a USB HID device itself. Like I said, there is a newer one that does. But this has 2 cores. It runs at a ridiculous clock speed and has lots of memory. It's got a fuckload of GPIO pins on it. It's also expensive. Like even before the chip shortage, I think these were like $12 or $15 a piece. And that would get expensive fast, hooking a bunch of these up to a bunch of old computers. So we're going to try to stay away from that if we can. You're getting up into the price range where it's a little, well, it's still cheaper than a Raspberry Pi Zero, but if you're deploying a lot of them, but if you're just doing a one-off thing, it might be a little easier to use a Pi Zero than one of these. But if you had to make several things with, you know what I'm saying. So yeah, I don't know. There's a keyboard library that somebody on Geekhack wrote called TMK Keyboard that runs on these Arduino Leonardo clones, and it takes a bunch of different keyboard protocols like from the keyboard, like you can hook ADB or XT or Sun or whatever keyboards up to these microcontrollers, and then it converts it into the USB HID protocol so that you can use them with modern PCs or Macs or whatever, which is cool. But we're kind of wanting to go the opposite direction. But I'm hoping I can use that library for reference somewhat. The PS2 protocol is well documented, and there's code out there for acting like a PS2 keyboard. So that shouldn't be, a tremendous deal. And hopefully we can do that on the cheap stuff. The ADB protocol is documented. There are a couple of projects that convert ADB to PS2, I think, or vice versa. Maybe USB. I can't recall. The USB Wombat. Yeah, well, ADB Wombat. I can't remember what it is. It's the same guy that makes the floppy emu makes that. I don't know if that's an open source project or not. If it is, I can probably use some of it for reference. But it'll be challenging to get some of this code. A lot of this code is designed to run on these teensy microcontrollers. It may be something of a challenge to get it to work right on these ESP8266 boards. Because I'm sure the timing requirements are different and all of that. So I don't know. I'm going to fart around with it one of these days, though. But it's going to be a little bit, like I said yesterday, I have some other projects that I need to, wrap up before getting into some of this other stuff. I don't want to spread myself so thin like I usually do. I want to actually get things done instead of starting stuff and never finishing it. You know what I'm saying? But we might as well get ahead of this and think about it some in the meantime. I'd like to know your all's opinion, if you maybe have any better ideas. So the whole idea here is you would run all of this on an encrypted Wi-Fi network that wasn't connected to the internet. You'd get like a cheap router, like a WRT54GL or something. You wouldn't even plug the WAN port in. You just set it up as a web router, and then all of this shit would connect to that. And you'd have a central, like probably a Raspberry Pi Zero with the keyboard and mouse plugged into it, that would talk to all of these modules, send keyboard data and mouse data to all of these modules, as well as have some shit on the GPIO header for switching between different machines, you know, which would basically just change which of these modules it was sending data to, you know what I'm saying? And since it would all be on an encrypted Wi-Fi network, I mean, hell, you could even turn off the SSID broadcast and nobody'd be able to figure out how to connect to it or sniff the data off of it very easily, I don't think. So I think it would be secure enough that way, even though it's a little bit scary to think about hooking your keyboard port up to the internet. This wouldn't be routable to the internet. It would just be its own Wi-Fi network. So yeah, what do you guys think? Do you have any better ideas? Do you have any experience doing this kind of stuff? Any advice or ideas that you've got would be pretty swell. All right, look down there in the thing if you want to join the Discord server. It's still out of control, but if you join, you can help us tame the Wild West. All right, thanks for joining me. Thanks for joining me this morning, gentlemen. I will see you in the next video.